All right, last section, 8.6, graphing rational equations. This is the advanced stuff. So just a quick little refresher. You know, yesterday, everything was in the form of, you know, we had like a over x minus h plus k. So basically an example of that would be you'd have something like, you know, 1 over x minus 4 plus 2. And we got some information from that. We knew what the parent function looked like. We knew the transformation. And so basically we always knew that this back number give us our horizontal asymptote. And whatever makes the bottom here 0, that was our vertical asymptote. And we kind of knew that, you know, we always started with our parent function, which had asymptotes at 0 and 0 that kind of look like that. You know, that's the function 1 over x. So that's kind of everything from yesterday. Well, that's one version. That's one form of rational equations. The other form is when you have other stuff on top like this. So in general, these ones we kind of just refer to as some function over some other function. You know, some p function, some q function, where like on this one we have a quadratic on top and a linear term on the bottom. So these are handled a little bit differently. There's some overlap, but these are a little bit more complicated. So let's kind of jump right into this thing. So it says the graphs of some rational functions are not hyperbolas. Consider the following function below. So I want to kind of start with graphing this thing, and then I want to kind of go through and look at a few key features of it. So the first thing I noticed looking at this is I know that on the bottom I can't have 0. So I know that there's going to be an asymptote down there. So when I look here, I'm like, hey, x cannot be equal to 1, because that'll give me a 0 down there. So that means there's an asymptote there. So I have a vertical asymptote at x equals 1. You know, so if I start to kind of graph this thing, kind of have an idea that right here at x equals 1, we are going to have this vertical asymptote. So there's that spot. And then, you know, if I wanted to find the zeros of this function, so if we look for, you know, where are, get rid of the dotted line there. If we say where are the zeros, you know, aka x-intercept, because remember x-intercepts are zeros. Well, this function is going to equal 0 when the top equals 0. You know, if this is 0, the only thing we got to worry about is when is this denominator, or the numerator I should say, when's the top going to be 0? Well, it's going to be 0 when x equals 3 and when x equals -2. So that's where the whole function is going to 0 out. So I'm going to have zeros at x equals 3 and -2. So I'm going to go over here to my graph and put in those zeros, or those x-intercepts, at 3 and at -2. Well, I really don't have a lot of other information right now. So I could start just making a table. I could do an XY table. Or right now you could go to your graphing calculator. Let's do this on the graphing calculator. I'll show you once with graphing calculator. Then we'll probably use Desmos for the other ones. The thing that I want you to understand with a graphing calculator is in order to input this, you have to put a second set of parentheses around the top. And then divide by the x minus 1. You know, because you can't really put that bar there. So you got to have double parentheses to keep all that stuff together before you divide. So I'm going to punch this into the calculator, and you can kind of look at my keystrokes here. So let's open this thing up. And we'll move it over here. Make it a little bit smaller. Get back over here. All right, so let's go to y equals. Clear out what we have. Some old stuff from chapter 7 in there. And I'm going to do a double parenthesis to show the whole top. Then the first parenthesis is x minus 3. And then the second parenthesis is x plus 2. X plus 2. Now I got to close it with the final parentheses. So now the whole top is in there. And then we need to divide it by, and you got to use parentheses here, x minus 1. So all these parentheses are kind of why I really prefer Desmos over the graphing calculator. I just wish there was a way that people couldn't communicate with each other. Otherwise, I would use it on the test. So I put that in there. And let's look at our window. Just make sure I'm in a standard window here. Zoom, standard. All right, well, when I look at that thing, it doesn't look like there's a horizontal asymptote. It looks like I do have that vertical asymptote. You know, when I go back and I look at my work over there, it does look like there's a vertical asymptote, you know, right there at 2. Like I can kind of see that on this picture right here. You can kind of see that asymptote, or not at 2, at 1 actually, my bad. I can see that, but there is no horizontal asymptote for this one. And I could go to my table, and I could get like a little bit more into it. So maybe I go to my table, I go second table, and if I look at that, I could get some extra points that might be helpful. So let's just kind of put a few more points on here. So it looks like at -1, I got to go up 2. And I'll just kind of put some more lines on my paper here. So at -1, we go up 2. And at 0, we are at 6. So 1, 2, 3, 4, 5, 6 would be right up here somewhere. And then I don't really show any more negatives, but it's kind of taken off down low. So I'm going to hold off for there a second. Then over to the other side, at 1 we show an error, which that makes sense because there's an asymptote. At 2 I'm at -4. So I'm kind of down in this direction. 3 I'm at 0. I knew that. 4 I'm up at 2. So I kind of have that going on. So, you know, these dots kind of start to jive with the picture. And maybe if I wanted like to know where -3 was, I could go over here and I could go to like -2 and -3. Kind of go that way, just to get a few more dots. So at -3, I'm at 1.5, or -1.5. At -4, I'm at 2.8. So it kind of looks like we got something like that and something like that. So the big idea I want you to push is this one had no horizontal asymptote. It kind of looks like what we were doing before, but not exactly. So we've answered the question though. You know, we have our vertical asymptote. We know the zeros. Those are kind of the two most important features of today's. And then we're going to get a little bit more into when do you have a horizontal asymptote and when don't you. But I just wanted to do it once on the calculator. Because these graphs are going to be really hard to do by hand. You're either going to have to make a table, or I'd prefer you to use Desmos or a graphing calculator and use the table on there. All right, so we're going to get rid of that. Let's go down to this next one, and let's see what we got going here. So it says identify the zeros. So remember, 0 is just another name for x-intercept, and the vertical asymptotes. So we need both of those. Well, the zeros are going to happen when the top equals 0. So we got to kind of go in here, and the best thing to do is always factor this thing first. So this is really x plus 6 times x plus 1 all over x plus 3. All right, so that's what I have. Always factor it first. And I can now see where the zeros are. The zeros come from up here. So I'm going to have a 0 at x equals -6 and x equals -1. So go to my graph. And 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. We'll go a little further because we do have a 0 at -6. And kind of put some on the top. I don't really know how far we're going, but it's a start. So -6, 3. So there's 1 0. Here is another 0. And looking at my vertical asymptote, well, the vertical asymptote comes from when's the problem on the bottom? Well, there's a problem on the bottom when x equals -3. So there's going to be a vertical asymptote right there at -3. So let's kind of put him on there. Okay. And now after this, we're kind of in a bit of a pickle. Not really sure, what this one looks like. So maybe now we go to Desmos. Let's check this one out. So you could either put the original equation on top, or you could put the one on the bottom. I'm going to do the bottom one. X plus 6, x plus 1 over x plus 3. So let's go. X plus 6 it'd actually be easier to do the top equation. Maybe I'll just do that. I think it'll be faster. So that was x squared plus 7x plus 6, all divided by, looks like it didn't do it. Looks like I had to, looks like I do have to put parentheses around this part, because it doesn't really know, am I dividing by the whole thing? There we go, divided by, and what we had on the bottom, we had x plus 3. And it looks like we got the same type of thing going on. I don't see a horizontal, but there is that vertical, it appears right there at x equals -3. If I need a table in Desmos, I can go up here to the little gear, and I can click table, and I can see some numbers here. So if I want it to be kind of nice, I can just use those numbers there and get a little bit better. Like I see a y-intercept of 2, and then at 2 I'm almost up to 5. So you kind of get the idea, and you can actually type in any numbers you want. I could type in 7.5 if I want to. And with Desmos, you can kind of create your own table and tailor it. You could skip around to whatever number you want to. But either way, we kind of have an idea of the picture. So I'm going to go back to the notes there and open these up. And I'm just going to kind of sketch roughly what the thing looked like. Kind of came from down here, did one of these numbers, came from here, did one of those numbers. But again, no horizontal asymptote. So I want to kind of go through a little bit of a summary. So you're kind of going to know, like, when are there going to be asymptotes, when are there not going to be asymptotes. So in this situation, if it's in this form, P over X thing, okay, as opposed to, the other form that we're talking about was the A over X minus H plus K form. He's kind of got, this one has its own people. All right, so when this happens, here's what I want you to remember. If you are top heavy, and you might be like, well, what the heck? What do you mean by top heavy? I'll explain that in a second. But if you're top heavy, then you're going to have no horizontal asymptote. And what I mean by top heavy is, in both of the equations above, when you look at the biggest term, we had like an x squared on top, and then the biggest term on bottom was an x. So the top was top heavy. It had more x's. So that last example looked like this. So when I'm talking about the top heavy part, I'm meaning that the lead exponent is bigger than the lead exponent, which would be a 1, down here on the bottom. So I'm calling that top heavy. When the top is bigger than the bottom, there's no horizontal asymptote. All right? Now, if you are bottom heavy, all right? If you are bottom heavy, then your horizontal asymptote is going to be at y equals 0. All right? So that means, so a scenario of this, an example of this situation would be if I have something like, x plus 4 over, x squared minus 2x plus 1. I am going to have an asymptote, but it's going to be at y equals 0. It's going to be interesting, though. It's a different type of asymptote, but just kind of keep that in mind. This will be something you want to put on your cheat sheet. And then if there's a tie, all right, if there's a tie, then it's going to be the leading coefficient of P over the lead coefficient of Q. So meaning, like, let's say that we have an example where we have, like, I don't know, 3x squared plus 4x minus 5. And on bottom we just have x squared plus 2x minus 1. Well, if that's the scenario, I'm like, well, wait a minute. I got a tie. All right, here's the tie. The 2 kind of tells me that man, we're in a tie right now. So all we're going to focus on are the lead coefficients. And I have a 3 and I have a 1. So that fraction right there, 3 over 1, that's going to tell me that I'm going to have a horizontal asymptote at the line y equals 3. All right, I know this is kind of tricky. It's a lot to keep track of. It's kind of why I broke it into 2 different sections. But if you can remember this table, you'll be in pretty good shape. You'll always be able to kind of graph it and look at it too, although sometimes the asymptotes are a little bit tougher to see. Remember over here in the easy form, this number right here, that was the horizontal asymptote. And when this was 0, that gave you the vertical asymptote. All right, it's that h or whatever when you get a 0 there on the bottom. So yes, 8.5, that section was pretty straightforward, pretty easy. A lot less to remember. All right, well, let's get into this, and I think it'll be easier once we start working. So what we need to do, we need to identify the zeros and the asymptotes, both horizontal and vertical, and we got to sketch the graph. So let's get after it. So zeros, let's first do the zeros. So the 0, aka the x-intercept, well, we got to figure out the top. We need to do some factoring. So this thing is really, this is x plus 3 times x minus 2 all over x. Well, my zeros then, it looks like are going to occur at x equals -3 and positive 2. So I have my zeros there. Now I started thinking about asymptotes. Well, for a vertical asymptote, it's when this bottom is 0. So the vertical asymptote is going to come from this part. And I'm like, hey, x equals 0 is going to be an asymptote because that's not allowed. All right, so you're not going to be able to have an x of 0. And then if I look at horizontal asymptotes, well, I look at the situation. I'm like, hey, this is top heavy. That's 2 and that's a 1. So remember, if this is top heavy, then, and maybe I shouldn't go over that far. Maybe I should kind of write it below it so I have room to graph. This is going to be none. All right, and the reason being is we are top heavy. Now, we really don't have a lot to graph from just that information, but we kind of have a bit of a start. So I kind of have my graph, and I have zeros at -3 and 2. So I do know it crosses there and it crosses there. And where's my vertical asymptote? Well, my vertical asymptote is at 0. So I can put that guy on the grid. And now really to get any other points, we'd have to make a table. We'd either have to make a table by hand or we'd have to use Desmos or a graphing calculator to do that. So let's just bust that out real quick. X squared plus x minus 6. So x squared y equals parentheses x squared plus x minus 6. And then divide that by just an x on the bottom. That's all we had. So it looks like we do have that asymptote at 0. We do have our 2 points. And if we needed other points, if we wanted to go to the table, we could kind of go in there and we could get some better points. You know, it looks like 1, -4, 1, -4, -1, 6. So I could kind of steal some of that. 1, -4, -1, 6. So over 1, down 4, 1, 6. And we know it's going to look something. I guess my asymptote maker is still on, but you know what I mean. The lines are going to look like that. All right, so we got our zeros, we got our asymptotes, we set the graph, good to go. Let's go to the next one. All right, so next problem. Right away, I kind of notice that this thing is bottom heavy. I see an x to the first, x squared, so I know it's bottom heavy. So we're going to have another asymptote that we didn't have before. But let's go through it. Let's do it in order. So first thing I want to look at is where are the zeros? This doggone button doesn't turn off the dash the way I like it. So the zeros are when the top equals 0. So that's going to be x equals 1. All right. So there's only 1 0 there. And then for our asymptotes, well, the vertical asymptote is dictated by the bottom. And what's not allowed on the bottom? Well, we're not allowed to have x equals 0 for our vertical asymptote, because that would give me an undefined function. So the bottom is there. And now for the horizontal asymptote, I'm like, well, this thing is bottom heavy. And I know when it's bottom heavy, that tells me that I'm going to have a horizontal asymptote at x equals 0. So both of our axes, and hopefully you got more room than me and you can kind of smash this in here because you don't want to crowd over into number 4 on your paper. But I'm going to have my grid, and actually on my grid, I'm going to have an asymptote here. I'm going to have an asymptote here. And I do have a 0, which this is a little bit like odd. It's kind of like, well, wait a minute. How come we have a 0 at x equals 1, but there's an asymptote there? So occasionally, in these rare situations, you can cross an asymptote. Asymptotes are really, what they do is they're like a magnet for end behavior. It's like wherever the function is going towards the end, it like you're eventually approaching that number and then not crossing it. But you can cross it in the early part, and we really haven't had any freak cases like this. But this is a freak case. And I just kind of want to show you what's going to happen. You know, by hand, we could make a little table. And, I don't know, maybe I'll just show you how to do that if you weren't really sure. We know that we can't have 0 in there because that will screw up the bottom. But let's put a 1 in there. If I put a 1 in there, the top's going to be 0. And the bottom's going to be 1. And 0 divided by 1 is 0. So I knew that. I got that point right there. Let's stick a 2 in there. If I put a 2 in there, I got 2 take away 1 all over 2 squared. So it looks like 2 is a quarter. So when I go over 2, I'm up a quarter. And let's go to 3. Well, if I put 3 in there, I get a 2 on top and a 9 on bottom. 2 ninths. Well, that's even less than a quarter. So now we're coming down some. And if I put a 4 in there, I get 3 over 16, which is an even smaller fraction. So what's happening is this thing is getting lower and lower and lower over here, and it never crosses the asymptote. But let's look at, you know, kind of what happens, you know, at say between right in here, maybe at 0.5. Well, if I put a 0.5 in, 0.5 take away 1, well, that's negative 0.5. And when I put a 0.5 on the bottom, I get 0.25. Well, that's a negative divided by a positive. That's going to be a negative number. And what ends up happening is this thing kind of comes up. It cracks over the asymptote, but then as it goes to infinity, it never touches the asymptote again. So this is one of those rare cases where you can bust through the asymptote. All right? And then I'm not going to do all the negative points, but let's go to Desmos and see what we have. So x minus 1 over x squared. So x minus 1 x minus 1 divided by x squared. Oh, I need divided by bar. X squared. And look at that thing. It's kind of weird looking. So on the left, it looks like how we've normally been seeing it. But then on the right, it busts through, and then it comes back. So when we have these bottom-heavy ones like this, you know, sometimes they get a little bit weird. And I don't expect you to be able to graph that by hand. I plan on you using a graphing, you know, device to kind of get this thing squared away. But to finish your notes, we now know that this guy just does the normal thing over here on the left-hand side. So that's kind of strange. All right, let's go to number 4. I'll zip through this a little faster. So for zeros, that is, well, when is the top 0? If I factor a 2 out of there, I get 2 times x squared minus 1. I might as well just keep factoring this whole thing. Actually, I'm going to go over here where I have a little bit more room. So on the top, I have 2x squared minus 2. On the bottom, x squared minus 4. Let's factor that all out. 2 times x squared minus 1. Well, down here, this is x plus 2, x minus 2. And actually on top, I can factor that. And you always want to factor all this out because you're going to see in a second, weird stuff happens when you can cancel people out, when you graph. All right, now I kind of can see what's happening. So I got this here, and I look at for my zeros. I'm like, all right, what's up with these zeros? Well, the zeros come from the top, and I get -1 and 1. So I want to slap these on here. I want to slap -1 and 1 in the mix. And then, you know, then I got, where are my asymptotes at? Where are my vertical asymptotes? So my vertical asymptotes come from the bottom. So that comes from when x is -2 and 2. So holy smokes, I got 2 vertical asymptotes. This is weird. Missed my mark a little bit. Come on, man. Give me a dotted line for crying out loud. And I got another one here. So I now have 3 regions, all right? And then let's see about the horizontal asymptote, because I noticed there's a tie up here. So I'm like, all right, what about the horizontal asymptote? Well, since there is a tie, the horizontal asymptote are just the coefficients, which this was 2 over 1. So that's going to be at y equals 2. So I have another asymptote chilling right here. Now, I'm going to save you kind of the legwork, but when you go and you graph this thing, I'm not going to make you watch me type it through Desmos again. But when you go to do this one goes up, down, and then you have this over here and this over here. You know, but pretend those are all solid lines and not dotted lines. So this one is really weird looking. All right? So when there's a tie, you get this really odd shape looking graph. So the big thing is it bottom heavy? Is it top heavy? Is there a tie? And make sure you can use your graphing calculator to kind of help you out. The holes here are pretty easy. Holes occur basically when you can cancel something out on the top and bottom. So the directions say identify the holes, then graph. These are actually super easy. So if I look at the top, this is x plus 2, x minus 2. And this is over x plus 2. So when I cancel out, that thing that I just canceled out, whenever that happens, I'm like, oh crap, there's going to be a hole at x equals -2. All right? That factor of x plus 2, it's kind of like, well, there was going to be a 0 there, but because there was a top and a bottom, there's actually a hole. You know, x is not allowed to be -2. It's not going to be an asymptote. There's going to be a hole. And if I looked at the surviving equation, what's left is f of x equals just a linear, just a line. So this is kind of what I'm referring to as the surviving equation. He's what's left after the battle. All right, well, he's easy to graph. If I wanted to graph y equals x minus 2, it's just a line. You know, it cuts through right here at -2, has a slope of 1, and it's going to go, you know, up through. Well, but then I got to put in a hole at -2. So I got to go back on my graph, and I got to kind of erase a little tiny spot and be like, wait a minute, there is this undefined value there. And if you actually looked on the graphing calculator Desmos, you won't see the hole on the graph. But if you go to the table, you know, if you go to the table, you'll see a whole bunch of values, but when you get to the -2, it'll say undefined or error. So that's what it actually looks like. These are just going to be lines with a hole in them when you have something cancel out. So this one over here, this will be what? An x plus 3, x minus 2. I got an x minus 2 on the bottom. So u canceled. So that means we have a hole at x equals +2, because that's what made it undefined. It used to make asymptotes, but since there's one on top and bottom, it's actually a hole now. And the surviving equation is just y equals x plus 3. So that says go up 3, do like that, slope of 1, and then throw a hole in there at 2. So at 1, 2, we got to go back in and be like, you know what? There's a break in the line, and there's a hole there. Now, whenever you have a hole there, this is called a discontinuous function. It's discontinuous, all right? Meaning there is a break somewhere, all right? It's not smooth. Everything we've done so far this year has been smooth. The lines just go up, they go down, they keep going. Parabolas, lines, I don't care what we are. This is the first time where we had a gap or a break in our line, all right? So these holes make it, this is called a discontinuous function when this happens. All right, I know this is a lot to throw at you, but hopefully it makes a little bit of sense, and definitely you need reps like anything else. See you.